Hey everybody, Mr. Bowman here. In this video, we're looking at the Year 10 mid-year exam from 2025. So this might be a useful resource for future mid-year exams if you're kind of maybe doing your maths at Westlake boys. We've got some instructions here. I won't bore you with those, but the important part is this exam comprised of 3 different parts. I suppose technically 4, but the first part was an overview of your statistics section. We then had probability. Both of those were worth 25%, so 50% combined. Finally, the big section, algebra, 50%, probably the most important thing in terms of your Year 10 maths development. And then finally, at the very end, there was an optional extension section with 0%, doesn't count towards the overall grade, so it didn't count towards that. But it was just a good way to show some extra skills, particularly if you're in the extension classes. So that was the cover sheet. Below that, you were given an information sheet, and these were just some useful kind of abbreviations to do with your stats to help you memorize things you potentially might want to analyze. You also had some probability and statistics formulas that were also relevant there. If there were any formulas that you need, we did put them in there for you. So this year's sheet may look a little bit different because there may be different questions needing different formulas, but have a look there if you're not sure in an exam. So scrolling down, that page was left deliberately blank just to make sure the odd and even numbers were a bit balanced. So let's get straight into question or section A. This is the stat section. We tried to start each section with 5 multi-choice questions. And for each of these questions, we were really clear. You could only respond with one answer. So if you're circling 2 because you maybe weren't sure between which 2 to pick, you were going to get those marks wrong. So let's get into question number 1. So question number 1, what is the definition of a median? So we've been asked for a definition of the median in a numerical data set. So the definition of a median is the kind of the middle value, the value that's in the very center of the data, the 50% mark. So let's go through the options. So option number A, the number that appears the most, that's not the median, that's the mode. So we know it's not going to be that option there. B is the average of all the data sets. So that's a bit vague. The word average doesn't really actually mean anything because mean, median, mode are all different types of averages. So that's kind of a bit of a useless definition. The middle value, when the data is arranged in order, that sounds exactly what we're looking for. So I think it's going to be that answer. Let's circle it, but let's read the next one. D, the difference between the highest and the lowest. And that there's actually the range, that definition there. So it's definitely not that one there. So C is the answer to that one there. If you got C right, you were going to get a developing mark. So moving on to question 2, which of the following is not a measure of center? So we actually just talked about that. So the center are your mean, median, modes. So mean, median, mode, which is actually the first 3 options, mean, median, mean, mode. So all of those are measures of center, which it has to be that range is the thing that's not a measure of center. And the range, if you remember, is actually a measure of spread or a measure of variability, how much the data varies. So D would be the right answer there. And again, if you got that right, you're getting a developing mark. So moving down to 3 and 4, scroll down so I can see both. So the below graph is a distribution of the class's results in a recent quiz. Which of the following best describes the distribution's shape? So this is the distribution in the graph that they're talking about. And when you're chatting about the distribution in the graph, you're generally talking about one of 2 things. Is it symmetrical or not symmetrical? In this case, it's clearly not symmetrical. If we draw a line in the middle, that right-hand side definitely doesn't match up with that left-hand side. So it's not symmetrical. So seeing that as one of the options is C. Let's cross out C. We know it's not going to be that. If it's asymmetrical, which it has here, there could be a tail. So drawing a little sketch. So if you've got a graph that looks like this, you can see there's a tail over here on the right-hand side. That would be an example of right skew data. And all the other way around, you had a tail there on the right. Well, that was a bad diagram. You had a tail there on the left-hand side and a big clump there. So that there wouldn't be an example of left skew data. And in our case, I think we've got that because we've got a clump of data here on the right-hand side, and then it's got been dragged over here to the left-hand side. So that looks like a left tail to me. So I think A, left skewed, is the answer there. And because this was all about the shape of a distribution, this is a new skill to year 10. That was the first of the achieved marks in there. So carrying on to question 4, which was using the graph from question 3, what is the mode of this? So remember, the mode is the most common value. In that case, it's going to be this big peak kind of sitting down here on the right-hand side, and that was 100% in this case. So wherever that peak is, that will be an example of the mode. And the mode is a review from year 9, so that made it a developing mark. And then scrolling up to the last multi-choice question, what describes the scatter of that? So if you think of tarsog, scatter was one of the options. So the two options for scatter were, it could have been a constant, which kind of looked the graph, if I drew a graph like that, it's when all the dots kind of would fit within the same train track, and that wasn't really fanning out. Or alternatively, it could have been non-constant. So those are the two options, and that is when the dots maybe fan out. You can see the dots there getting wider, they're fanning out. So it had to be one of those options. So it's not B and it's not D. So that was linear, not linear. It's not one of those. This graph here, I can see if I'm drawing my lines, if I'm starting over here down the beginning, I can genuinely follow it down this way here, and I can follow it down this way here, and I can see that fanning out. So that definitely looks like a fan, and that matches the non-constant graph that I described earlier. So I think the answer is going to be C here. And if you weren't getting that right, that was an achieved mark because that was a new skill in year 10. So scrolling down, so for questions 6 to 9, use the box or whisker graph here, and we've got that graph there. And where's it? There you go. Let's do that. So we can see 6, 7, 8. 9 must be on the next page. We'll get to that shortly. So question 6, what is the highest score across the two classes? So the highest score is going to be up over here somewhere on the right-hand side. And lining up this dot here, so this one here is the highest from class B. And if you go up to the top there, that looks like it's 93. So 93% was the maximum from class B, which is the highest. And that was with the developing mark. Don't forget your units there as a percentage. Calculate the interquartile range. Just a reminder, if I scroll up to the formula sheet, interquartile range was actually given to us, right? Upper quartile minus lower quartile. That's what the UQ and LQ mean. So let's jot that formula down first. So my interquartile range is going to be my upper quartile minus my lower quartile. And this is for class B. We're not doing both, class B. So the upper quartile is the right-hand side of the box, which was 87 in this case. So it's going to be 87 minus the lower quartile, which is the bottom side of the box there, which was 73. And 87 minus 73 is 14. If you got that one there right, that was what you needed to get an achieve mark. Remember, we wanted to see some working, so make sure you're not taking shortcuts. Make sure you're including that working to get those full marks. So question 8, describe the shape of class A's result. So this one's quite a difficult question because the shape is normally best seen, if I circle it on the left-hand side, normally best seen by a dot plot. But we can also see shape in box or whisker graphs too. And what you can genuinely see is, if you look at the whiskers for both parts, so that whisker and that whisker there, that's roughly the same. And the median, which is in the middle, that's roughly in the middle of that box. Not perfectly in the middle, but roughly in the middle of the box here. So as a result, I think class A has a symmetrical shape. So that kind of tells me, if I draw a line down the middle, it kind of tells me this side here is roughly the same as the side here. So we have that element of symmetry. So we're going to start by just stating that really clearly. So I see that the shape of class B, or class A rather, class A's distribution of test scores or I've nearly written in, is symmetrical. And I just want to note a few things about that answer. I've clearly stated it's symmetrical, and I've also used the context. I've talked about the test scores, I've talked about class A, I've even used the word shape in there. So don't just say it's symmetrical. Go a bit further to make sure you're getting those marks. So the reason it's symmetrical was roughly, if we think of the middle, so the middle was at 77. So the top 50% goes from 77 all the way up to 85. So that has a difference of 8. And the bottom goes from 77 down to 70, and that has a difference of 7. So there's a slight difference there of 1, but that's all good in terms of symmetry. It doesn't have to be perfect, but we can see the top 50% is roughly the same as the bottom 50%. So I see, so let's talk about this. So it is symmetrical. So I'm now trying to justify my answer. Well, forgive my bad spelling. I think I've had a nightmare spelling that, but I will go with it. It is symmetrical as the as the top 50% of test scores sits between 77 and 85%, which is a variation of 8. And then we've got, and the bottom 50%, oh sorry, let's actually full stop that. This is similar to the bottom 50% of test scores which sits between 70 and 77%, which is a variation of 7. So there's really good evidence, really good way to justify using the top and bottom 50% to make sure that. So if you told me it was symmetrical, that's how we gave you an achieve mark. If you were then able to justify it with some kind of reference to numbers, that's how you're able to get that full merit mark. Okay, so moving down to question number 9. This is the excellence question. This is quite a lengthy question. And there's heaps that we needed to talk about and discuss here. So using CSSI, so remember that center, well, I suppose we should jot that down. So if we write it down here, so we had CSSI, so that was center, it was shape, it was spread, and it was interesting. So that's kind of the CSSI that we've been looking at. We've been asked to write one comparative paragraph for each of those. So basically we need 4 paragraphs, and we've been really clear. We've told you each paragraph should have these 4 things, so 4 sentences. So there's 4 paragraphs, and each of these paragraphs have 4 sentences. So we'll try to make it really, really clear what we're expecting of you. Now the trick with this question is center, shape, spread. You were expected to know what each of those meant. So the center of a data is a comparison of the median for both groups. So you had the median for class A and the median for class B, and you were comparing them. The shape, we've already kind of talked about that. That was the symmetry, potentially like left and right skew, if it was an issue. Spread is the interquartile range, and anything interesting is kind of your unusual points, your outliers is another way to describe those. And I just want to know, if you scroll back up to the graph, which I'm going to do for you, the graphs looked pretty reasonable. So I would say there was nothing really interesting about that graph. So there was that outlier discussion is probably an irrelevant one. I wouldn't stress about that one too much. And I should also note, whilst I'm only going to discuss the interquartile range for the spread, you could also maybe talk about the range for that value as well. But I'm going to stick to the interquartile range for this video example. Let's get straight into the center. I'm not going to write out the whole thing step by step. I'll pause the video and show you kind of my answer for each. But the center is a discussion of the median. And we can see here, class B, that's got a median of 80. So let's write 80 underneath here. And we can see class C, that's got a median, sorry, class A, that's got a median of 77. So we can see here the center of class B is larger than the center of class A. And we kind of need to put that in a sentence. Remember, we need to follow this 4-step process, and I'll write down my answer, then show you and talk you through that. Hey, so I've just popped up with my model answer. I've tried to color code it for us. So the first step to any answer is just clearly stating what you see for both of the two groups. So that's my green sentences, and I've tried to bullet point it to make it easy to read. So really simply, I've said, I see that class B has a median of 80%. I've then moved on to class A. I also see that class A has a median of 77%. So that was just stating what we see. So the orange sentence, we call this the comparative sentence. So I've circled the word comparing there. And that is us specifically saying bigger, smaller, same, some kind of comparative word. And I can see my comparative word here is larger. So this tells us that Class B's test median was 3% larger than Class A's test median, or whatever it was. So really, really important, that comparative word, larger, smaller, bigger, taller, heavier, whatever it might be, is essential for that there. And then finally, that last sentence there, I've tried to link it to context or explain what it means somehow. And then what I thought was, if the Class B, they've got a higher center, higher median, maybe their teacher is more experienced. So I've written that down. Maybe they've got a more experienced teacher, or potentially maybe they're an extension class, and you'd expect an extension class to have students who maybe will get a couple % more on their test. Okay, so we're now moving on to the shape discussion. I've just kind of started my answer. We'll talk about it, and then I'll kind of bring in the color coding again. So I've calculated the interquartile range. So 14% was actually from a previous question. And then I've now gone ahead and calculated, well, Class A had an interquartile range of 9%. So the interquartile range here is all about the variation kind of sitting within the box part of the box or whisker. Forgive me as the computer warning comes on. We'll carry on through though. So if it has a larger interquartile range, that means the variation. All right, so I've now added on my shape discussion, and hopefully you can kind of see the same kind of vibe again. The green stuff is my observations for what I'm saying. So I see that Class B has an interquartile range of 14%. That's my clear statement of what I'm seeing in relation to the shape for Class B. Then moving on to Class A, I see the shape of Class A has an interquartile range of 9%. So again, a clear statement. Orange is my comparison. So as we talked about previously, the interquartile range is all about how much variation we expect to see in the middle, 50%. So I'm expecting to see a larger variation in the middle 50% of Class B versus Class A. That's what I've talked about there in the orange. And then finally, you might want to think about, what bits from the context may give you larger variation. And I thought, well, class sizes are really important. If there's heaps of people in the class, you'd expect to see more varied results. And maybe in Class A, maybe it's a smaller class. Maybe there's only like 15 people in there. And as a result, there's less people, so you're expecting to see less variation. I've just realized that whole discussion there was actually about the spread, wasn't it? So I just had the wrong heading there. So let's update that heading. So that was all about the spread. And then the final section is all about the shape of the data. And the shape of the data, remember, we kind of alluded to it before, but it's all about the idea of symmetry or lack of symmetry in it. So let's start by discussing Class B. So I'm not going to write this out fully right now. I'm just going to write down the numbers. But Class B, if you look at the top 50% of the graph, that varies from 80, which is the median, all the way up to 93. So that's got a variation of 13%. And then if you do that to the bottom 50%, that goes from 72 up to that 80. So that had a variation of 8%. So you can see 8% and 13% are quite different from each other. And that confirms, if I'm drawing the circle on the graph, that confirms we had a bit of a right tail on that data. We can then do the same thing for Class A. And again, I always compare just the top 50% with the bottom 50% of the graphs. I'll write B50 in this case here. And we actually did these previously, didn't we? But the bottom 50% went from 77 to 70. So that had a variation of 70%. And the top one went from 77 to 85, I think it is. And that there had a variation of 8%. And we can see those are really similar, telling us it's symmetrical. And these are a little bit different, telling us it's not symmetrical. So I'm going to pause again, and in a little bit, I'm going to write really small, but I'm going to pop up with my discussion here. I'll probably not write about the red one in this comment, just to save time and a bit of space, but I'll maybe talk to that as well. Okay, so I've squeezed in my shape discussion over there. So we left off at these numbers over here. I've then talked about the top and bottom 50%, and then I finally came to the conclusion that for Class B, it had a right skew, which meant there was a right tail. That's why the top 50% was bigger. I then did the same for Class A, but because it was 8% and 7%, that told me it was roughly the same, which suggested there was a bit of symmetry happening there. And then in orange, I've got my comparative statement. My comparative here are, I suppose it's not really heavier or taller, it's just that the shapes are different. One's symmetrical, one's not symmetrical. And then after that, you might have added a red comment, why was the shapes different? So it might have been, this group up here on the red. Oh, sorry, I've circled an orange. That might be some extension students. They're all in the same class, so it kind of dragged out the right tail in that direction. And there might not have been any of these extension students in this class there. There could have been a whole host of reasons. As long as you told me something that contextually made a bit of sense, you're going to get the full marks for that. So in terms of the marking for this question, it was the excellence question. If you were able to do 2 complete paragraphs, so if you did the center stuff here with all 3 colors, and then maybe the spread stuff here with all 3 colors, you are going to get 1 excellence mark. If you got all 3 of them with all 3 correct colors, noting we didn't do the red one here, but you needed to do the red one. If you got 3 out of 3, that made 2 excellence marks, so basically an E8. If you weren't able to get excellences, if you maybe didn't have the red stuff, if you couldn't think of the right context, you were still able to get merit. And if you maybe weren't able to be comparative, so maybe you weren't able to do these orange paragraphs, you lacked that comparative nature, you just had that green stuff really, that's how you got achieved. But we were really keen on seeing at least one of these comparative comments. So you did need at least one of those. But if you struggled with the others and only got to green, that would have been okay. And I should note for merit, it was 2 kind of correct orange comments for merit, 1 with the other green stuff for the achieved sections. Okay, just scrolling down, nearly finished kind of the stats section. You see the beginning of section B just over here, but we've got this remaining, this scatter plot type graph to look at here. So for questions 10 to 30, use this graph. The graph is comparing the number of hours exercised per week and a person's resting heart rate, and a bit of context from a PE class, so we know it's about school kids. We can see that in the graph. We've got hours per week of exercise, resting heart rate. So it looks like the more you exercise, the lower kind of your resting heart rate goes. So question number 10, 1 student from the PE class exercised for 3.5 hours per week. Estimate their resting heart rate. So 3.5 hours per week will kind of be somewhere in this area here. So what we need to do to respond to this question is from there we're going to go up to the graph. And then once you've done that, we're going to go across to the resting heart rate. So I think it's going to be about 65 beats per minute is what BPM stands for. So 65 beats per minute. If you were able to get that right, you got an achieved mark. So the next question is describe the relationship of the graph. And you remember TARSOG, relationship was all about if it was kind of weak, moderate, or strong. So let's write that down. So weak, moderate, or strong. So it had to be one of those. In this case here, we can see the dots are kind of hugging that trend line really, really well. So for me, I think this is a clear case that it is strong. It has a strong relationship. If you're able to do that, you got achieved. I want to note sometimes it's a bit vague. Sometimes it's moderate, maybe strong. You don't know which one, in which case we'll accept both. But in this case, it was really, really clear. So if you told me it was moderate, if you told me it was weak, you were getting no marks in this case. So moving down to question 12, which is the very last question of the exam, and it was with a merit mark as well, which is nice. If someone starts exercising more, what changes in the heart rate are you expecting to see? And you've been asked to justify your response. So the changes that I'm expecting to see, if someone starts exercising more, so that means if we look at their bottom axis, someone maybe starts over here and they go across the axis here, we would expect their heart rate to go from up here, maybe from there. So the heart rate's going to go down. So we need to justify that. And if you are insightful enough, you might have spotted, well, that's all about the association of the graph, right? Because the association for TARSOG was positive or negative. So we had a negative association, and then that tells us about what change we're expecting to see. So let's start by actually talking about the association. So I can see that the relationship between a student's, again, I'm using context, a student's hours of exercise per week and their resting heart rate is negative. So that's kind of my stats part of it. So we now need to talk about, well, what does negative actually mean? So a negative association means a person's change in heart rate, so change in exercise per week would have the opposite change in their resting heart rate. Or written heart. Oh gosh, Control C, get rid of that. Heart rate. So basically that opposite there means if one goes up, the other goes down. If one goes down, the other goes up. So this means, let's actually answer the question now. This means if someone starts exercising more, which was the question, this means if someone starts exercising more, we would expect their resting heart rate to decrease. And I think that wraps up the question. I've definitely justified my answer. I've talked a lot about the negative association and its implications. And then after that, I've clearly said it's going to decrease. And that wraps up the actual question that we're being asked. Well, let's scroll back up this page because we can now start that 25% probability section. And similar vibe to the previous sections, we start off with 5 multi-choice questions. So let's get into the first multi-choice question first. So which of the following words means probability? And this was a Te Reo Māori question. I want to note it was developing, so it didn't officially impact your grade, but just curious to see how many people knew it. And in this case here, it was C. And if you're able to get that right, you got the developing mark. A few of the others mean, for example, that top one there, that means, I think that was algebra. And there's a few other kind of cool keywords coming from that as well. So moving on to question 2, how many face cards are included in a standard pack of cards? So face cards are cards with, if you interpret it literally, cards with a face on it. So that's the jacks, the queens, and the kings. And there's 4 of each of these. The 4 representing each of the suits, spades, hearts, diamonds, clubs. So 4 times 3 is 12. So that means B was the right answer for that one. And if you got that one there, that was a developing mark as well. Moving down so we can see the remaining 3 questions. So question 3, if a coin and a 6-sided dice are thrown as part of a game, how many unique combinations are there? And this here, you might have discussed it in class. This was all about sample space. And the best way to look at sample space is drawing a table. So let's draw a little table. So let's go heads and tails. So this side here represents the dice. Sorry, not the dice, the coin. And the top side of my table represented 1, 2, 3, 4, 5, 6. They were the different outcomes. And if you have a look, we could have had 6 different outcomes along here, and we could have had 6 different outcomes along here. That would have been 12 in total. So we had 12C as the answer. And if you were able to get that, that was quite a tough one. Sample space is new in year 11. Year 10, and it is looked at in year 11 as well. But that was an achieve mark if you got that. Moving on to question 4, what would best describe the probability of being attacked by a shark the next time you go for a swim at the beach? So it's not guaranteed to happen. That's definitely not the case. It's not most likely. But in this case, it would be unlikely to happen. And if you got that, that was a developing. All right, moving on to question number 5. A bag of marble contains 5 reds, 3 blues, and 2 greens. So if we think of that, it would have been red, 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 red. And then we would have had 3 Bs, BBB there. And then we had some greens. So that there all would have been the marbles inside the bag. Ben draws 1 marble at random. What's the probability he got a blue one? So we know that there's 10 in total. And we had 3 blues, so that would have been 3 out of 10. The issue is all of the options are in decimals, so we'll need to change my fraction 3 out of 10 into a decimal. And when you do that on the calculator, that would have got you to 0.3. So that means option A was the correct answer there. And if you got that right, that one was a developing mark. So scrolling down to questions Up the top there, question 6 to question 8. So a student flips a coin 1,000 times and records their results. 67 of them land on heads and 33 of them land on tails. What is the theoretical probability of the coin landing on heads? So remember, theoretical probability is not based on the experiment that the student just done. It's based on kind of you just thinking about the scenario. So in this case, the theoretical probability of getting heads would have been 1/2 or 0.5, because it would have been 1 out of 2 of the outcomes. Moving on to question number 7, what was the experimental probability of it landing on heads? And the experimental probability is the probability that we then use the recorded data to calculate that. So in this case, it's going to be 67 out of 100. So 67 out of the 100 of the student's experiment was that, and if you put that into a decimal, that was 0.67. So these two here, the marking was combined. If you got both of these correct, you were awarded an achieve mark. If you only got one of them right, you got the developing mark. So moving down to question number 8, do you think the coin is fair? So a fair coin would be 50-50. The experiment had 67 out of 100, so that's quite dissimilar to the 50-50. So we would have expected 50 of the 100 to be heads or close to it. Justify your reference with the theoretical and experimental probabilities. So that last part's basically saying if you don't use the two probabilities above that you just calculated, you're not going to be able to get full marks. Okay, so in this case here, I'm thinking the coin's unfair because 67 or 0.67 is really, really far away. So let's start by talking about the probabilities, and then we can link into the fair or not fair stuff part of it. So we know that the theoretical probability of getting a heads is 0.5, which is quite far away from the experimental probability of 0.67. So let's talk about the difference, because the key thing is the difference is quite significant. This difference is significant and suggests that the coin is not fair. So just to recap that, if you talked about the 0.5 and the 0.67 and then made a clear statement that it's not fair because of that difference, that was what you're going to do to get that merit mark. So moving back up the top here, so we're now on to question 9 to question 13. So we've got a two-way table scenario here. So the following two table shows the number of junior students. So the junior students are either year 9 or year 10, circled in the diagram, and who brings their lunch from home or buys their lunch. And we can see that they're bringing the lunch or buying the lunch. The table is partially completed. We also know that there are 80 students who took part of the survey, 40 from each year level. So it's really important. In the paragraphs, they often hide numbers that need to go into the table. So we'll remember that later on. So question 9 rather, the first question is basically complete the table. So we're going to need to put these numbers in here to that table. So we clearly said there were 40 from each year level. So 40 year 9s, 40 year 10s, comprising of the 80 in total. So we fill that in from the text, and the rest has to be filled in by using our math skills to complete the rest of the table. So I guess the easiest one to figure out is we know this group here plus 10 has to be equal to 40. So that missing number must be 30. That means we can then figure out this bottom one down here, because 14 plus 30 must come to that bottom. So that's going to be, what, 44, which means that has to be 36. And that was 80 minus 44 to get me to that 36. And then finally, up the top here, this number plus 10 has to be equal to that 36. So that's going to be 26. And 26 was my last number, so it's good just to check it going in the other direction. And we know that 14 plus 26 is 40. So it means if that last number is right, I've probably done it right the whole way through. Okay, so we've done that one there. If you got the full table correct, you were able to get an achieved mark in that instance. So moving on over to question number 10, how many students were year 9 and bought their lunch from home? So year 9 and bought their lunch from home. So year 9s are over here, brings the lunch from home is over here. So it must be these 14 people over here. So there are 14 people that meet that definition. And that there was a developing mark because you were just reading from one of the numbers that were given to you. Moving down to question number 11, what is the probability that a randomly selected student from the survey would buy their lunch? So because it's a probability question, we've gone from reading the table to calculating something from the table. So this is what's going to make it an achieved mark if you are able to get it. So a probability, remember, a probability is a fraction, f over t, favorable outcomes divided by total outcomes. So we've been asked about random students, and anyone from the survey would be a random student. So our total that we're curious about for this question is going to be the 80. So 80 is the total, and from that 80 total, how many people bought their lunch? There's that 44 down the bottom, isn't it? Oh, sorry, bought their lunch. I'll circle the wrong one. That would be the 36 coming down from the bottom. So they've bought, as in purchased, their lunch at school. So that there would be 36 out of 80. Fraction is enough to get you your marks for that. If you wanted to simplify the fraction, 9 out of 20, that would have got you the marks too. And if you converted that to a decimal, 0.45, that would have got you the mark as well. So any three of those ones that I've circled is enough to get those marks. Okay, now moving down to question number 12 and 13, and they carry on from the same table, so I might have to go back and forth like that. So if you were talking to a random student who buys their lunch, so we've gone away from being a random student to a random student who buys their lunch. So we now only care about the students who buys their lunch. What is the probability that they were from year 9? So we're going to follow the same approach as the previous question. So we're going to use f over t, but instead of caring about all 80 people for the previous question, we now only care about the people who are buying their lunch. So we only care about these 36 people over here. So that's going to become the denominator, that total part of my fraction. So let's write down that down the bottom. So we've got out of 36. Of those 36, who are from year 9? And that's going to be the 26 sitting up the top of that fraction. So 26, let's draw that in there. And then same thing as the previous question, you could simplify your fraction. In this case, it would be 13 out of 18, or you could convert it to a decimal, 0.7222. Remember, if you do convert it to a decimal, 40p is the rounding you need to do if it's a bit of a messy rounding situation. So if you got that right, I think that was a really nice merit question, but merit's what you got, and that's because it was conditional probability. It meant that denominator had changed. So we're now down to question number 13, and question number 13 was one of the excellence questions from this probability section. So the school canteen knows that there are 500 year 10 students. So straight away, as soon as I'm seeing a big number, remember, that normally tells you it's going to be something to do with expected number in probability. So expected number, and you might have seen this formula, expected number is equal to n times p. So I'm thinking I'm probably going to be using that formula already. So 500 of them are year 10. How many of them would you expect to buy their lunch? And that word expect kind of confirms it's that expected number formula. And we're buying their lunch. So let's go with f over t. And like we did in the previous question, we know it's only year 10 students that we're calculating. And what we're working towards is my expected number formula is n times p. N, I know, is going to be the 500 given to me in the question. And p is the probability, the probability of the thing we're looking for. And we're looking for the probability that a random year 10 student bought their lunch. So let's find that probability using my f over t approach. So scrolling up to the top, how many year 10s were there? So there were 40 year 10s, weren't there? So let's do that. So that's going to be the numerator. So 40 year 10s, and of these year 10s, how many of them bought their lunch? It was buying their lunch, it was 10. So we got 10 out of 14. And then if you simplify that, that would have got you to 0.25. That's the decimal version. So now that we've got that, we can then use our n times p formula. So remember, 500 was n. and we're going to multiply that by 0.25. And what that's going to do is that's going to break up the 500 year 10s. It's going to find a quarter of them to answer the question. So if we do that, 500 times 0.25, that is equal to 125. And if you got that, I thought that was a really good expected or a really good excellence mark in terms of the maths and the requirements in that section. So moving down, we're now looking at question number 14 and 15. So during a sunny day on term 1, a school did a survey of how students got to school. The probabilities of each group are outlined below. So students could have got to school by catching the bus, by a car, walking, cycling, or maybe there was some other thing, or maybe like a scooter or whatever it might have been. So I've got to scroll down by mistake. There it is. And one thing to note, that other one is actually missing because that relates to the first question there. Find the probability that the person was other. And the way you would have needed to do that is all of these probabilities here, including the missing one, has to add to 1. So other would be 1 minus the other numbers. So minus 0.47, minus 0.28, minus 0.15, and then minus 0.02. Plug that into your calculator, you get 0.08. So about 8% of students get there via other means. And if you got that right, that was worth an achieved mark. So scrolling down to question number 15. So during term 3, Auckland Transport wants to know the proportion of students who are catching the bus to school. The school decided not to conduct another survey and told them 0.52. Do you agree with this response? Gosh, so there's a lot to unpack for this question. This one was quite tricky. So if you're reading the context, so this survey here was about a sunny day on term 1. We're now in term 3, which remember, term 3 is all about winter. So the way I would be thinking is 0.52 and 0.47 and 0.52, these numbers are different. So clearly what the school has done is they've just like added on 5% to suggest, well, more people are busing to school in term 3 than it would have been in term 1. And that's probably going to be these people who are walking. So these people who are walking, probably okay to walk in term 1 when it's sunny, but they're probably going to think of other ways to get to school in winter when it's raining or term 3. So I disagree with their number because it seems like they've randomly made up 0.52. It's not the number on the table, but we don't exactly know where it's come from. So let's start talking about that. So let's disagree. So I disagree with the school's response of, oh gosh, my handwriting's so messy here, of 0.52. So the term 1 probability is 0.47, which occurred on a sunny day. I would expect the 0.15 people who walk during a sunny day to take other forms of transport, other forms of transport to school during a term 3. However, the school has added 5% to the busing number, and we have no way of knowing if this is actually correct. Gosh, so a bit of a long response, but we got there. So we knew it's 0.47, and the school randomly replied with 0.52, which might be close, but we actually have no idea. That's 0.15 walkers. We've actually got no idea how many of them are going to switch to busing, and that's ultimately why we disagreed with the school's response. So we're now up to question number 16 and 18. These are the last questions in the probability section. And they're all to do with the trees. And trees tend to be the hardest section of the year 10 probability exam. So make sure it's one you're confident with, because you might be able to pick up a few marks extra that maybe some of your peers might miss out on. So we've got a prize game that has happened during the school event. A participant is drawing 2 balls from a bag. During the process, the first ball is not put back before the second ball is drawn. And if you look down to the table, you can see how the probabilities are changing between the first and the second draw, and that reflects that. So once you've taken out the first ball, the options to pick from for the second ball does change. Okay, so there are 10 balls in the bag in total. 3 of them are green and 7 of them are red, and the prizes are dependent on the balls selected and are outlined below. So if you get 2 of the green ones, you get a big prize, whatever that is. 2 red ones, you get a small kind of consolation prize maybe, or if you get 1 of each, you get no prize. And we were really nice. In this exam here, we actually gave you the fully complete probability tree, so that's a pretty good exam as far as I'm aware. So question number 16, calculate the probability the random participant draws a green ball first and then a red ball second. So the first thing to figure out is there are 4 outcomes at the end of your probability tree. We'll ignore that red warning sign for now. And we need to figure out, well, which of these relates to green and then red. So if we follow the first one there, so there's the green one to start off with, and there's the red one. So we're looking for this branch over here. So to find the probability of that, we need to multiply the probabilities that are kind of in those circles. So that there would be 3 out of 10. We need to times it by 7 out of 9. And that there would be 27 out of 90. And you could simplify that quite a bit. And that could get you to 7 out of 10 if you simplify the fraction, or it could get you to 0.2333 with a 4DP rounding if you convert it to decimals. But any 3 of those, whichever one you put in, you would have got 4 marks. And if you did get that right, that was worth an achieved mark. So going down to question number 17, calculate the probability that a random participant wins a prize. Scroll up to the tree to help us with the numbers. So a prize, if you remember, was 2 green or 2 red. So if you think of those branches, it would have been, this one here is green, green. So this branch here would have won a prize. And then red, red down the bottom, that branch there would have won a prize. So either of those is going to get you a prize. So the first thing is, let's find the probability of green, green. So the probability of green, green is going to be equal to 3 out of 10 times by 2 out of 9, and that there gave me 6 out of 90. I then need to do the same for red, red. So probability of red and red. Following the trees, remember you got your 2 probabilities along the tree. So that's 7 out of 10 times by 6 over 9. So we've got 7 over 10 times by 6 over 9, and that there is 42 over 90. So quite a good chance of winning that prize. That means the overall probability of winning a prize, that is these 2 added together. So if you add together the numerator, so that's 6 plus 42, so that's 48. So the overall probability of winning a prize is 48 out of 90. So that's more than 50-50, which is pretty good chance of winning a prize. And again, same thing as the other questions. You could simplify that fraction. So that would simplify to 8 over 15. Or alternatively, you could put that into a decimal, 0.5333, and that had a 4DP rounding. And again, any correct version of those would have got you the merit market for this question here. If you calculated one of these 2 probabilities correct, the 6 out of 90 or the 42 out of 90, we gave you like the part achieved mark for that question. So the next one, so that's the probability of a prize, and that question actually relates a little bit to what we need to do next. So during the event, the organisers decide to change the process that the balls are being drawn. They decide now they have to put the ball back instead of kind of keeping it to the side. So that means the probability tree up here, this second half is going to change. So instead of the probability changing, because you're not putting the ball back, the probabilities are now going to stay the same. So 3 out of 10 and 7 out of 10 are going to be the probabilities for the next layer of the tree, because we've changed that process. It's now going to look different. So let's draw that probability tree. So I suppose the first split was, so if we had green and red, so green was 3 out of 10, wasn't it? And then red was 7 out of 10. So that was the first branch. That's unchanged to the next one. However, it then says the first ball is put back before the second ball is drawn. So when I draw my next layer, green and red, the probability is going to stay the same. So that's going to stay at 3 out of 10, and that's going to stay at 7 out of 10 for red. And we're repeating that same for the next layer. So we've got 3 out of 10 here, and then 7 out of 10 over here. And the question we've got here is, what would the impact of winning a prize be? So how is the number we just calculated, so we just calculated the probability of winning a prize, 0.5333, how is that number going to change based on my new scenario? So remember, the prize outcomes are going to be green, green up here, and then red, red down here. So we need to figure out, well, what's the probability of winning a prize based on this new scenario? So let's go new scenario. So the probability of green, green is going to be 3 out of 10 times by 3 out of 10. Remember, that was the two probabilities multiplied together. So that's going to become 9 out of 100. We then need to do the same for the second prize, which is red, red. That was 7 out of 10 times 7 out of 10. So we've got 7 over 10 times by 7 over 10, and that there is 49 out of 100. And the probability of a prize, based on this new scenario, is those two added together. So 9 plus 49 is 58. So it's going to be 58 out of 100. And if you convert that to a decimal, that's 0.58. And the reason I converted it to a decimal was I wanted to compare the number 0 to the previous one of 0.53. So let's incorporate that as part of the answer. So let's write down here next to it the old scenario. So the probability of winning a prize was 0.5333. So the question did specifically say, how would this impact the probability? So we need to be really clear. So we can see clearly it had a positive change, right? The probability of winning a prize is increased, but we want to go beyond that. So instead of just saying it's increased, we want to come up with a number. So we want to talk about that impact. So let's write change in probability. So change in probability, I think I spelled probability wrong there, but that's all right, we'll just go with it, is 0.58 minus 0.5333. And plugging that into the calculator, that's going to be what? 0.4667. So that's almost 5%. So let's go, that's approximately 5%. So the statement that we want to conclude with is the probability of getting a prize has increased. So let's put this all into words. So the probability of getting a prize has increased from 0.5333 to 0.58, which is an increase of approximately 5%. There you go. So if you were able to come up with the calculations and get that 5% number and then communicate exactly what that impact was, you were able to get that excellence mark. And that, I should note, was like the hard excellence question. So that was the type of mark to be the difference between E7 and E8. Okay, so we've officially done that probability section. So we're now going to move on to part C, which is the 50% algebra section. So it's a big, important section. So it's one you really, really need to be confident on leading up to this exam. So same thing, the question or the section starts off with multi-choice questions. This time around there's 8, and you need one answer for each. So question number 1 what does tauranga mean? So tauranga is the word for algebra in Te Reo Māori, and again, that was with the developing mark, so it wouldn't impact if you kind of got achieved or not in that one, but just a nice little question to get us going in that section. So question number 2, what fraction is not equivalent, so get rid of that. So what fraction is not equivalent to 3/5? So 3/5, remember, if you can multiply the top and the bottom by the same number to get one of the options, that will be an equivalent fraction. So for example, that first one there, if I did times 11 to the top and the bottom, that would be 33/55. So that means question A is an equivalent fraction because I could do it to the same number for both. So let's get rid of that. That's not right. So times 2, so times 2 times 2, that would get you to 6/10. So I know that one's not an equivalent fraction. Sorry, that is an equivalent fraction. For the next question there, if I go times 10, it gets me to 30, times 10 gets me to 50. So C would be an equivalent fraction, which means D has to be the right answer because 30 is times 10, and then to get to 55, that's times 11. That's a different number, so that's a completely different fraction. So that means D was the correct answer there, and that was worth a developing mark if you're able to get that one here. So question number 3, evaluate the cube root of 729. This one here is one that you could just do in the calculator, but the logic behind that is you need to think of a number that times by itself 3 times, so repeat multiplication of 3, that gets you to that. And in this case here, if you did 9 times 9, that gets you to 81, times by 9 again, that gets you to 729. So that means 9 was the answer, and the calculator would have helped you get to that. And if you're able to get 9, you got your developing mark there. Question number 4, if A is equal to 2, B is equal to 4, so we've got 2, 4, C is equal to 6. Use your substitution skills to find out A, B minus C. So A, B means A times B. So A times B in this case, so 2 times 4 is going to be 8, isn't it? And then we had a minus C, so that was 6. Remember, C was 6. So we had minus 6, which means 2, and hopefully that's one of the options, and it is. So B was my option here. That was correct, and that gave you a developing mark as well. Which of the following, for question number 5, which of the following is odd one out? And this one here all relates to the relationship between, we'll call it fractions, decimals, and percentages, because you can have equivalent, you can just kind of flip-flop between different versions of these, right? And they all have the same meaning or the same answer. So in this case here, I think the answer, I've tried to trick the answer when I wrote it, but 10% as a decimal would be 0.1, which as a fraction would be 1/10. So all of those three, A, C, and D, all of those three are related to each other in terms of the fraction, decimal, and percentage relationship. So that means the correct answer would have been B, 10. So 10 is just a number. It's kind of put in there to trick you to see if you can figure out the difference between them. But B is the answer for that. And again, if you got that one right, you would have got a developing mark. So question number 6, which of the following is not an equivalent to the others? Well, let's just try to simplify each of these, might be the best way to do it. So question number A, y times y, well, that's going to become 2y. Y times y, so that's repeat multiplication. So that's going to become y squared. So straight away I'm seeing, well, those are different to each other. 2 times y is equal to 2y, and well, 2y is already the answer. So we can see A, C, and D, all of them simplify to 2y, but B simplifies to y squared, which means B is the odd one out, or not an equivalent expression to the others. So if you were able to get that for question 6, that was worth a developing mark as well. Scrolling on up to question number 7. If you were to evaluate 6 times the square root of 5 minus 1 plus 3 using BEDMAS, remember BEDMAS, you might have heard it known as GEMMA now. That was a thing to do with the curriculum change. Which operation would you do first? So in this case here, you're going to be doing the maths that's inside the square root first, because inside that square root, you would have your invisible brackets, which would have been grouped together or would have been stuck inside the bracket. So you've got to do that first. So the operation we're doing first is we need to do that minus 1. So we need to do 5 minus 1 as my first bit of the answer over here. And if you got that right, that was worth a developing mark. And then the final multi-choice question, question number 8. Which of the following would result in a positive answer? Gosh, okay, so negative times positive. So negative times positive is always equal to negative. 0 minus a negative. So remember, if you're, let's just make up some numbers. 0 minus a negative, so let's say negative 2. Remember, minusing a negative becomes plus, so that would have become 0 plus 2, which would have been 2. So that there is a positive answer, isn't it? So I'm thinking the answer is going to be B. Let's circle that, but let's double check the other ones. So negative plus a negative, let's make up some numbers. Negative 2 plus negative 5. So what this means is we're starting off at negative 2, and we're getting more negative. So that there would actually be negative 7. So that's still a negative answer. So it's definitely not that one. And then the same thing, positive divided by negative, we know that's going to be negative. So I'm happy with my answer for B. And this was the first of the achieved marks in this section. So that one was quite tricky to get the B as the right answer. So moving on over to question number 11. Question 9 to 11. And it has been really clear here. It says to use your number skills in these sections. So we're not quite, even though it's the algebra section, there's still a few number skills that we want to get you to look at. So question number 9, a shopping mall charges shoppers a constant rate for the parking. So constant means it's the same thing. So if a shopper is charged $10.50 for 3 hours, how much would you expect to pay for 5.5 hours of parking? So the first thing we need to do is we need to find out what's the hourly charge. What's this constant hourly rate that they're asking us to pay? So we're going to go 10.5 divided by 3. And if you did that, so that tells you they're going to charge $3.50 per hour. So we now need to multiply that by 5.5 to get to the right answer. So that's going to be 3.5 times by 5.5 hours. And when you do that, plug it onto your calculator, you should get $19.25. So if you are able to get that with some correct working, you are going to get an achieved mark. So question number 10, a recipe that feeds 3 people requires 3/4 of a cup. So 3 people means 3/4 of a cup of flour. How much flour is needed for 10 people? So what we need to do is we need to figure out the per person, per person, how much flour do they need? So we're going to go, so it's 3/4, and we need to divide that by 3. And if you do that on the calculator or with kind of a bit of mental math, you're going to get to 1/4. And it makes sense, 1/4 plus 1/4 plus 1/4, so that's 3/4. So 1/4 of a cup per person. We're looking to extend that to 10, so we need to multiply that. So actually, right, let's write 1/4 cup per person, just to explain our answer a bit better. So we're then going to do 1/4 of the cup per person. We're going to multiply that by 10. That gets me to 10 over 4, which is 2.5. Or you could write 2.5 as a mixed number if you needed to. But that means we need 2.5 cups of flour, I think it was. Was it flour? Yep, of flour to feed 10 people with that same recipe. If you were able to get that, you got an achieved mark as well. If you got the 1/4 of a cup per person number, that was the developing mark for that one there. So scrolling down, question number 11. A science exam has 90 questions covering biology and chemistry at a ratio of 3:2. So it looks like it's a ratio question. If you need 75% to pass each section, how many questions would you need to pass the chemistry section? So the first thing we're going to do is this 90, we're going to split it up to the ratio of 3:2. So what we're going to need to do is we're going to need to divide that by 5. And if you divide that by 5, that's 18. So that means each part of the ratio is going to be 18. So if we have 3/2, so that means that's going to be 3 times 18. And that's going to match the 2 times 18. Do you see how I'm multiplying each part of the ratio by 18? And when I simplify or calculate all that, so I'm going to get 54 to 36. So that means, remember the 54 is biology and the 36 is chemistry. There's 54 biology questions and 36 chemistry questions. And the chemistry ones are the part the questions are looking at us. So if you need 75% to pass this chemistry section, so what we're then going to do is we're going to multiply this number. So 36 times by 0.75, which is the decimal value of 75%, that there would be 27. We're going to put that, because it's a merit question, let's put that in context. So the student needs So the student needs 27 questions correct to pass the chemistry section. Okay, and that one there was quite a nice one. That was quite tough. Like the maths requirement of that was a bit greater than the other questions, but that's reflected in the merit mark you were awarded for that. So that was a nice merit mark floating around in there. So moving on down, so question 12 to 15, read each of the question, form an expression. So I've seen that word expression a few times this year. So form an expression, that means a little bit of algebra, doesn't it? So form an algebra that represents the scenario. Your expression must include the variable given in each question. So variable given in each question. So don't make up your own letter. Use the one you're given. You can see here N, X, H. So you don't need to make up your own letter. Use the one that you're given. So let's start off with question number 12. An unknown number is doubled. So we know doubled is the same as times 2. And then increased by 7. And we know increased by 7, that's the same as a plus 7, isn't it? So that expression is therefore going to be 2n, which is the doubling, and we then need to add 7. So if you got that right, that was a developing mark, mainly because that question kind of comes from the Year 9 curriculum. So going down to question number 13, an unknown number x is squared. So we know x squared would look a little bit like that, and then increased by 3, and then again increased by 3 is plus 3. So what have we got? So let's write that down. So we've got x squared plus 3. So we've got that so far. The result is then square rooted. So remember, square root is those funny looking sides there like that. Form an expression to describe the scenario. So what we're going to do is we're going to put a big square root around my x squared plus 3. So moving down to question number 14 and then 15 after that. So determine the price of plumbing jobs. The plumber multiplies the hours worked. So we've seen the word multiplies there. So when something's being multiplied by $65 per hour and adds on a call-out fee. If the plumber works 8 hours from a recent job, form an expression. So what we're going to do is we're going to go 65 times by h. So that's the hourly component of the work and the cost that they're doing. And the $80 call-out fee is just plus 80. Plus 80. So if you're able to get that, you got an achieved mark over there. Now going down to question number 15. 3 consecutive numbers were summed together. So remember, consecutive numbers is something we should probably talk about first. So they've said y is the first number there as well. We should talk about that. So if y is the first number, the next number would have been y plus 1. And then the number after that would have been y plus 2. The number after that would have been y plus 3, and so on. So those make it all consecutive. And that's because, 4, 5, 6, 7, all of those are consecutive numbers because we're adding on 1 every time. So I suppose going back to this question here, we were asked about 3 consecutive numbers. So if y is the first number, y plus 1 has to be the second number, which means y plus 2 is going to be the third of those numbers. So it said these numbers here are all summed together. So if I sum these all up, I've got 3y plus 3. And that's because there are 3 y's here, and then we had a plus 3 kind of with the constants. It's then said the answer or the result is then cubed. And cubed is the same as a power of 3. So what we're going to do is we're going to put that in a bracket and then put a power of 3 there. So if you were able to get that one there gave you a merit mark. Okay, now moving down to questions 16 to 21, and these are fully simplified questions. So we'll go up to there. So question 16, you can see you got a whole bunch of x's, and all of them are being added or subtracted together. So here we're grouping like terms. So we've got the first 2, well, that's going to be 10x, and then we're going to minus another 7x, and that's going to become 3x. If you got that right, you were given a developing mark. Question number 17. Here we can see we're adding and subtracting again. We've only got minusing signs. So we can only minus the things that are like terms. So to see how you have a squared here and a squared here, we can subtract those. But in the middle, we've got a minus a. That's not an a squared, which means we can't put that together with the a squareds. So let's do the 10a squared minus 9a squared. That's going to become 1a squared or a squared. And we've got that minus a in the middle. There's nothing we can do that apart from just writing minus a. And I want to note, at no point here should we try to do some maths with the a squared and the a, because you can't subtract these things. They're different. If you are able to do that correctly, you were awarded an achieved mark. Now, multiplication is not what number 18 is all about, and that's way different to the adding and subtracting that we've just done. So we're looking to multiply the numbers together first. So 4 times 6 is 24. So we've got 24. We then deal with the letters alphabetically. We've got one A, so we can just put an A here. And then we've got B times B. That's repeat multiplication. So 2B's means B squared. And I want to emphasize the approach for multiplication is different to the approach for addition and subtraction. So that's why we can multiply the A's and the B's together like we did here, but we can't subtract the A squared and the A's that we've just done up there. So if you did that one right, you were able to get an achieved mark. So scrolling up to the next half of the page, so we're up to some division over here. Division's quite hard. So division has a similar approach to multiplication. You start off by using the numbers. So let's go 21 divided by 7. That's going to be a 3. We now deal with the letters alphabetically. We can see S cubed, and you can see there's no S's on the denominator. So we can just write down that S cubed exactly as it is. So we've got S cubed. And then the next thing, you can see a T squared on the top and a T squared on the bottom. So it's a little bit like, 7 divided by 7 is equal to 1. It's the same with T squared. So T squared divided by T squared is equal to 1. So if we multiply that by 1, we're left with what it is. So those T squareds actually have the effect of cancelling each other out. So if you're able to get that, so that's 3S cubed. That was given an achieved mark. We're now on to 20, which is all about multiplying again. And there's a bit of a trick to this one, actually. So remember, h squared is h times h. And then we've got to h cubed. That's 3 h's, isn't it? So that's h times h times h. And then we've got another h up here. So all of these h's, all 6 of them are being multiplied together. And that's an example of repeat multiplication, and that's a power. So there's 6 h's. So that's going to become h to the power of 6. And that will give you an achieved mark if you're able to do that one. We're now on to question number 21, which I should note was a merit mark. And we've got a messy algebraic expression, and there's a whole heap going on. We can see some addition, we can see some multiplication, we can see a big division. And when you're simplifying your algebraic expressions, and I should emphasize not solving, simplifying only, you're going to follow your GEMA or your BEDMAS in alphabetical order. I've forgotten the D in BEDMAS. There we go, BEDMAS. Okay, so the first thing to note were there any brackets? And in this case there was. The whole numerator has invisible brackets. So I've got to deal with that whole bracket happening. So inside that bracket, are there any powers? And I should note that y squared, that technically is a power as an exponent, but there's no actually maths to deal with that because it's just a y squared. We're not squaring a number, so we can leave that. Division, there's no multiplication. So there's no division there. There is some multiplication. So we're going to start by doing that multiplication. So we're going to write down 17y squared. That's the beginning of my answer, which is unchanged. We're going to add on 5y times 3y. So that's going to be 15y squared. And then that's going to be divided by 4y. Now I can carry on simplifying that numerator. So both of those are y squared, so I can add them together. So that's going to become 32y squared. And then that's divided by 4y. And this question now is similar to question 19 before. We can deal with the numbers first. So 32 divided by 4 is going to be 8. And then you've got y squared divided by y. And I'll write these out on the side. So y squared divided by y. Remember, y squared is y times y, which is divided by y. And one of the y's will cancel out the y on the bottom, leaving you with 1y. So the answer here is going to be 8y. So if you were able to get all the way to that 8y, you were awarded the merit mark there. So scrolling down a little bit more, so we're now moving on to some expanding questions by the looks of it. And again, in the exam, I've told you specifically what skill the section is looking for. So we've got expanding. And the way I teach my classes, I teach a bit of a rainbow method. So each rainbow, so it's going to be this times this. So that's one rainbow. So 3 times 2x, that's going to be 6x. And then we do the next rainbow. 3 times -5 is going to be -15. So that question there was worth a developing mark. Moving on to question 23, same approach. We're using our multiplying rainbow approach. We're going to do this times this. And it looks a bit messy, but we just do the numbers first. So 4 times 3 is 12. We've got two A's. We've got A at the beginning and then an a at the end, that's a squared, and then we've got 1b, which has out the brackets. We just leave that as it is. We then repeat the same by doing this times this. So there's no, well, it's going to be a minus sign. There's no other numbers apart from the 4, so we'll just write down a 4. There's only one a, so we can just write down the a. And then here we got b times b. That's repeat multiplication, so that's going to become b squared. Now that expanding was a bit more messy because of all the powers, and that there was an achieved mark if you were able to do that. We're now doing the same for 24, which is a double bracket approach. And we're going to do kind of double rainbows to reflect that. So we're going to start off with the first x out front. We're going to do x times x, which is x squared. We're then going to do x times 3, which is plus 3x. We're now going to repeat another rainbow for that 5. So along the bottom, so that times that. So that's going to be plus 5x. And then that times that, plus 15. So if you got to this stage here, that was the developing mark. You had to remember the question, I'm circling it above now, said to simplify as well. So these x's in the middle, 3x and 5x, they can be simplified or merged together. So that means we have 8 x's in total. So I need to rewrite that, simplify it. So it's going to be x squared, which was from the front. I'm going to add on my 8x, which is the simplified part, and then I've got the plus 15 at the end. Plus 15. And if you're able to get to that simplified step, you got an achieved mark there. And then finally, question number 25. This one was worth a merit mark because there's quite a lot of expanding to do here. We've got a single bracket expanding happening at the beginning of the question, and then a double bracket happening at the end. And then because you've got a whole bunch of variables from that expanding, you're probably going to have to simplify all of those together as you can, or however you can anyway. So let's start by doing this. Let's do the rainbow, single rainbow for the single bracket. So that times that, that's going to become 2x squared. And then we've got that times that minus 4x. Repeating the same over here, that times that, so that's going to become positive x squared. That times that, plus x. And then using the 3 now, so that's going to become plus 3x. And then that times that, plus 3. So I've expanded, I've got a whole lot going on here. I can see some x squareds. I can see some x's. And then I can see a number at the end as well. So let's put together all the x squareds together. So that there was 3x squared. 3x squared. We can then put together the x's. And the x's actually kind of cancel out because the x's over here, x plus 3x, that's 4x. And that will be cancelled out by the minus 4x. So there's no x's now. And then we can put the plus 3 at the end there. So if you're able to get to all of that, you are going to be awarded that merit mark. So scrolling down a little bit more, let's finish the bottom of that page. For questions 26 to 28, fully factorize. And again, factorize, we've given you the word there. And I want to note factorizing is probably the worst done skill, I think, in the algebra section. And remember, factorizing means your answer has to have brackets. So your answer must have brackets. And just as an example, a lot of people don't know what factorizing is, and they just do stuff with the numbers. So that, for example, here, a common one will be like 5x cubed, because they put the 2 and the 3 together, and then they put the x's together. And obviously, that's a really bad wrong answer, because there's not even any brackets anywhere, which means there's no way that could be the right answer. So you remember, factorizing, got to have some brackets as part of your answer. So if you do need to guess, make sure you're guessing something with some brackets. But hopefully you don't need to guess. So question 26. So 2x squared and 3x, they don't have any numbers in common because 2 and 3 are both prime numbers, but they both have an x in common. So x is going to be the thing that I'm factorizing. That's going to become out of the brackets. So because I've taken it out of the brackets, and if you remember from above, this rainbow method, everything was being multiplied together, wasn't it? Factorizing is the opposite of expanding. So the opposite of multiplying becomes dividing. So everything needs to be divided by this x, this common factor. So I'm going to go divide by x. So 2x squared divided by x is going to become 2x. And then divide the next part together as well. So 3x divided by x becomes 3. If you got that, you're able to get an achieved marker there. Going down to question 27, there's a bit more complications to this one here. We can see we've got some numbers now. 4 and 10, they both have a 2 in common. So I need to take out a 2. And I can see both parts have that b there as well. So I need to take out the 2 and the b, which is what's going to make this more complicated. I now need to do my opposite of expanding. So expanding was multiplying. I need now to do dividing. So I've got 2ab divided by 2b. So remember, 4 divided by 2 is 2. There's only one a there, so I can't do anything with the a. And then we've got b divided by b. They cancel each other out. So 2a is going to be left over there. I now need to, I'll put that minus sign there. I now need to repeat the same for the next step. So I've got 10 divided by 2 is 5. And then b divided by b, again, that's cancelled. So that there would be my answer. We can check our answer by expanding. So 2 times 2 is 4. And then you've got 4ab. So that matches the first part. And then you've got 2b times negative 5 is 10b. And that matches the second half as well. So if you're able to factorize there, you got an achieved mark. Scrolling down again, I'm assuming this next one's some double bracket expanding. Here we go, heaps of double bracket expandings. So if you remember x squared with the 3 components, so you've got x squared, x number, remember those all end up as a double bracket. So make sure you've got a double bracket to these ones. So let's get rid of all those and start talking about the approach. So the approach we need to take here is every double bracket one, you're going to have one in the middle, which is kind of your adding number, and you're going to have one at the end, which is your multiplying number. So the name of this game basically is you need to think of, well, 2 numbers that multiply to 16, but add to 10. So the way I start these questions is I think of numbers that multiply to 16. I'll try to get as many of them as I can. So I start off with 1 times 16, that's the obvious one. 4 times 4, 2 times 8, and then you keep going until you've got all of the numbers you can think of. And in this case, we've got all of them now. So now that you've got the multiplying numbers, you then need to think, well, these numbers, instead of multiplying, let's say I started adding them together, which of them would add to 10? And in this case, it would be that bottom pair there, right? Because 2 plus 8 gets me to 10. So those are going to be the numbers inside your brackets. So you're going to have x plus 2. That represents the positive 2 that we did in 2 times 8. And then you have x plus 8 for the other number. So we're repeating the same. This one's going to be a bit trickier, though. So we've now got things that multiply to negative 15 and add to negative 2. So again, same thing. We're going to write down all our times tables to 15. So that's going to be 1 times 15 and 3 times 5. I think that's actually all of them, isn't it? And because we're dealing with minus 15, we're thinking of differences. So we now need to think which of them have a difference of 2. And in that case, it's going to be this bottom one here, right? Because 3 and 5 have a difference of 2. And because they have a difference of 2, specifically negative 2, we need to make sure the bigger of them is negative in this case. And I should clarify, if that there was a plus sign, then it would have been the bigger one had to be positive. So just depending on whatever sign is there. So in this case, we're going to have, x minus 5 because the bigger number is negative. And then we've got x plus 3, the smaller number being positive. And then finally, this here is a special quadratic. It's for merit. And straight away, this is the kind of one either you know it or you don't. So because it's minus 81, we're trying to think, well, what's the square root of 81? And that's going to be 9. So our answer here is going to be x plus 9 and then x minus 9. So we have one of each, one positive, one negative. And if you're able to recognize it's one of those quadratics, a special quadratics, difference between 2 squares, you were awarded the merit mark there. Okay, so scrolling down to questions, I'll just scroll down. We're now solving by the looks of it. See how we've got the word solve there? Again, I've given you the word. So solving means we now have equations, and this is where we're doing our opposites. And I even said the word opposite in the question when I wrote this a few years ago. So the opposite of a plus is a minus, the opposite of a minus is a plus, multiplying and dividing opposites to each other as well. So you've got to be using your opposites to get here. So the name of the game is, we can see x kind of circled up the top there. We're looking to get that x by itself, which means that 7 needs to be moved to the other side. And that 7 is currently division. The opposite of division is multiplication. So that's going to become x is equal to 4 times 7. So hopefully you can see that there. That 7 there, it's been moved to the other side, is the opposite. Now that you've moved it, you can just calculate the answer. 7 times 4 is equal to 28. And if you got that one right, that was worth a developing mark. So moving to 32, just going to turn the page over with my answers as well. Same thing, we've got one letter here. In this case, the letter is y. And I now need to think this 8 and this negative 10. I need to move both of those to the other side because I want that y by itself. So same step. We need to think how do we get rid of these? And remember, BEDMAS is the way you decide how to move these, and we're solving, which is basically the process of working backwards to find out the answer. So we need to use BEDMAS backwards too when we decide. So we've got a times 8 over here, and we've got a minus 10. We need to decide with BEDMAS backwards which one to move first, and S for subtraction tells us we've got to move that subtraction first. So if I move that negative 10 to the other side, it's going to become positive 10. So we're going to have 8y is equal to 22 plus 10, which means 8y is equal to 32. So I've now cleared that. So that times 8 now needs to move to the other side as well. The opposite of a times 8 is a divide by 8. So we're going to have y is equal to 32 divided by 8. Y is equal to 4. And I should note, this is the solving method that I use with my Year 10 classes. Your teacher may have taught you some other solving methods, and whichever solving method you've used, for example, that last question, there would have been a plus 10 and a divide by 8 somewhere in that process. And if you have those, you'll be getting the full marks. And this one here was from the Year 9 curriculum because it was a 2-step question, so that was worth a developing mark there as well. So scrolling up, computer's being a bit laggy at the moment. So we're now on to question 33, and this is the first achieved mark. And the reason this is an achieved mark is because it's a fraction, which means the top is locked away. So in the previous question, we got rid of the subtraction first. Here, we have to leave that subtraction until the fraction is unlocked, and we can only get rid of the fraction by moving that divide by 3 over to the other side as a times 3. So that's going to become g minus 5 is equal to 6 times 3. Which means g minus 5 is equal to 18. Now I can move that minus 5 to the other side. The opposite of a minus 5 is a plus 5. So that's going to become g is equal to 18 plus 5, which means g is equal to 23. And because they had a trick to that one, that was worth an achieved mark. So moving down to 34, this one's kind of got a similar trick, but basically that letter H, that's locked away in the bracket. So I can't do anything with the 2, the H, or the negative 1 until my bracket is unlocked. So what I've taught my class to do here is this is a times 5 at the front. Same thing, let's move the times 5 out the way. So the opposite of a times 5 is a divide by 5. So that's going to become 2h minus 1 is equal to 20 divided by 5. 20 divided by 5 is 4, isn't it? So that's going to be 2h minus 1 is equal to 4. I can now move my negative, so let's move that over the other side. Negative 1 becomes plus 1. So 2h is equal to 4 plus 1. So 2h is equal to 5. And then we've got the times 2. Move it to the other side. Becomes a divide by 2. So that's 5 divided by 2. And in this case, h is equal to 2.5. And I want to note, you could have left it as a fraction, 5 over 2. Whichever one you picked, you would have got full marks for that. And that was worth an achieved mark. Obviously, that one was a lot harder than our previous one. Okay. So scrolling down, we're now on to 35. And this question, again, there's more tricks to that. We can see other questions, we only ever had one letter, but now we've got 2 letters. So before we can do our opposites and our moving stuff aside like we have done previously, we've got to simplify these letters. And my simplification process, I always think, which side, I've got the 5b on the left, the 2b on the right, which side of my equal sign, you can see my equal sign in the middle here, which side has more b's, and in this case it's this side here, and I think how many extra b's do they have? And in this case, there's 5 over there, 2 over there, so they've got 3 more, don't they? So I'm going to write down 3b here, 3b, and then I'm going to write plus 1 equals to minus 1, and basically those b's have cancelled out to become this 3b. And then now that I've done that, I can start my simplifying process or my solving process. So I'm going to move the plus 1 to the other side. The opposite of plus 1 is a minus 1. So 3b is equal to negative 2. My times 3, I'm going to move that to the other side. That becomes a divide by 3. So b is equal to negative 2 divided by 3. B is equal to 0. Well, I've got my negative sign here. We'll ignore that warning sign as well. Finish these solving ones. So that's negative 0.666, and then this is actually a recurring number, so that goes on forever. So we're now to question number 36. 36 was the last of the solving questions, and this one here with the merit mark, and again, it had its own tricks. But the initial thing to note is k plus 5 on the numerator, that's again locked away on a bracket. So all I can really do is move the 4 over to the other side. So I can't simplify the k's like I did previously, I've just got to move it over.
So that divided by 4 becomes a times 4. So that means k plus 5 is equal to negative 4k. Now this part here was quite tricky as well. I need to look at the k's and I need to think which side has more k's. And I should note, it's a really common error. This left-hand side, 1k is more than negative 4k. So they've got 5k's more. And another way to think about this question is you could think about moving negative 4k to the other side as well to join up with the positive k. And again, opposite to what you're doing. The opposite of a minus 4k is a plus 4k, isn't it? So what we could do is we could put a plus 4k on that side. So we've got k plus 5, and we're going to go plus 4k is equal to 0. And that's because there's nothing left on the right-hand side. I can simplify the plus k and the plus 4k together. So it's going to become 5k plus 5 is equal to 0. All right, so we can now move that plus 5k can move to the other side. So the opposite of a plus 5 is a minus 5. So that means we'll be left with 5k is equal to negative 5. Last step, that times 5 moves to the other side as a divide by 5. So that's going to become k is equal to negative 5 divided by 5. And I've done way too big of a working by showing you the extra steps, but I'll just do my answer here. And that there is equal to negative 1. So if you were able to get through all of those steps, you were awarded a merit mark. And for achieved, if you managed to simplify the k's together to get to that 5k, you were able to get an achieved mark even if you did make a math error floating around it. So that's pretty cool as well. So moving down a little bit, so we're now onto some of the more contextual questions, and you can see there's a bit of context to them. So for all of these, you've basically been asked to read them and answer them accordingly. So 37, we've been given a formula, and this formula here converts it between Fahrenheit and degrees Celsius. So it's a nice formula to know. And it looks a bit like some of the other solving questions we've done. We've been asked to use this formula to convert 14 degrees Fahrenheit into Celsius. So what we know here is we know that F is equal to 14. So I'm going to take away the F up there and put in 14. And that will leave me, once I show you, that'll leave me with an equation. So we've got 14 is equal to 5c over 9 minus 32. So you can see we've got an equation, and c is the only letter left up the top there. So that means we can use our opposites like we were just doing to solve that. So let's start by getting rid of the subtraction. So the opposite of a minus 32 is a plus 32. So that's going to become 14 plus 32 is equal to 5c over 9. So that becomes 46 is equal to 5c over 9. Now, just a reminder, the top of the fraction 5c is locked away with brackets, so I can't deal with that 5 yet. So the only thing I can do here is deal with that divide by 9. So moving divide by 9 to the other side becomes a times 9. So 46 times 9 is equal to 5c. And when you put that into your calculator, get 414 is equal to 5c. And then final step, that times by 5. I can now get access to it because I've kind of broken down that fraction. That fraction, I'm going to move over to the other side. So the multiplication becomes division. So that's going to become 414 divided by 5 is equal to c. And when I put that into my calculator, 414 divided by 5, that gets me to 82.6. So that means 14 degrees Fahrenheit is 82.6 degrees Celsius. And I just want to note, in this exam, we made a bit of a math error. So I think we got the letters or the equation wrong. So obviously that doesn't actually work in the real life. But you're able to get to C. And that was the correct answer based on the information you're given. And if you got all the way there, you were given a merit mark. Okay, so now moving down to 38. In 38, you can see there's a bit of a measurement geometry vibe to it based on that diagram, and it's worth a merit mark too, but it's the same process as our previous questions. You need to use some algebra to solve that. So the perimeter of the polygon can be determined by adding up each of the side lengths. And we know how to add together our algebraic expressions. So it looks like we need to do the same here. So we're going to add all those circled things together. If the perimeter is 54 centimeters, calculate x. So first, let's add together all of the the sides of it. So we're going to have 2x plus x plus 7 plus 2x plus 8 plus 5x plus 4, and then we've got plus 10. So from all of that, let's see how many x's we had. We had 2 x's, 3 x's, 5 x's, 10 x's. So all of the x's would come to 10. So we've got 10x, and then we can do the same with the numbers. We've got 7 plus 8 is 15, plus 4 is 9, plus another 10 is 29. Getting rid of all these circles. So we've got x plus 29. So we know 10x plus 29 is an expression for the perimeter, and we know that perimeter is equal to 54. So we can use that 54 by substituting it into our equation. So we know that 54 is equal to 10x plus 28. I can now do my opposite, so moving that over there. So that's going to become 54 minus 29 is equal to 10x. So 54 minus 29 is 25. So 25 is equal to 10x. I now move the 10 over the other side. That becomes divide by 10. So we're going to have 25 divided by 10 is equal to x. X is equal to 2.5. And in this case, centimeters. Don't forget the units for that one there. So we've now scrolled down to question number 39. And 39 is the first of the excellence questions. All right, so we have a question which is given up here. And basically this here is the students working. And they've got an answer of x equals to positive 3. And the question we've got here is, in which steps did the students make an error? We've been asked to describe the error and then suggest what should have been done instead. So in this case here, we purposefully put in 3 errors. If you spotted 2 of them and made a good suggestion, you would have got the E. So all you need to do is spot 2 of them. So the first one, if we look at step from the question to step 1, the first one was an expanding error. So they did 3 times x to get 3x was correct. And then they should have done 3 times minus 1, which should have been minus 3 there. So the first step they did was an expanding error. So let's describe that and then explain what they should have done instead. So error number 1. Error 1 was an expanding error. From the question to step number 1. So when expanding, and then we'll describe the error. When expanding, they wrote minus 1. Whoops, I've written a bracket there. So they've written down minus 1. This should have been minus 1 times by that 3, which was negative 3. So that was the first response there. So I've spotted the error, I've explained what it is, and I've explained what they should have done. We're now going to repeat that for a second error. And if we carry on the question below a bit more, so that should have been a 3. The second mistake that they made was, you can see this negative x, they've tried to move it over to here. And they've written negative 2x. So what they've done is they've done 3x minus x. So 3x minus x is 2x, and that's wrong because if you take the minus x to the other side, that should have become plus x. So that should have been 3x plus x, which gets you to 4x, not 2x. So that's the second error that they've made. So let's spot and explain that. So error number 2. So error 2 was a simplifying error. When moving negative x to the right-hand side, they left it as negative when that should have changed to positive. When that should have changed to positive. It should have been (3x plus x), which came to 4x. So again, like the previous response, I've stated what the error was, I've communicated what they've done, and then I've suggested what they should have done. And I won't fully describe the third one for you, so just a reminder, 2 was enough for excellence. But if you carry on a bit more, you would have spotted another mistake. So that -1, when it moves to the other side, it should have became a +1. So that would have been 9 plus 1 is 10. So that 8 over there should have been a 10, which means the final answer would have been 5 as well. So yeah, a few different mistakes there. Hopefully you're able to spot 2 of them. Okay, so now moving on to what question are we looking at? Question number 40. The product of 3 algebraic expressions is this thing over here. What are those 3 algebraic expressions? And the trick to this question was spotting that it was a quadratic. So a quadratic, that x squared means it's something that can be factorized. So the first step that I did was I also spotted that, do you see how each 3 components had an a? I'm going to single bracket factorize out that a. So that's going to become a, and then in bracket it's going to be x squared minus 7x minus 60. So once I've done that, this a here is going to be the first of the 3 things which are being products or multiplied together. The other 2 are going to be the brackets that are resulting from the factorizing of the quadratic that's left over. So if you think about this quadratic, what adds to -7 and multiplies to 12? Hopefully you're thinking the same as me. Hopefully you're thinking x minus 12, x plus 5, and that's because minus 12 plus 5 is -7, which was what we had in the middle, and then minus 12 times 5 is -60, which is what we had at the end. So once you've factorized it in this form here, you've got 3 things multiplying to each other. So the 3 expressions that are being multiplied, so the 3 expressions are, it's a, and then x minus 12, and then it's x plus 5. You could have had those in any order, but those are the 3 things. So doing that, and I guess the trick was spotting, well, that's something that could be factorized. Well, factorizing is the product or multiplication of different brackets, and that kind of then led you to the response. So moving down to question number 41. Explain why the expression below must always be positive. To be awarded, you must consider all scenarios. So this question, I think, was the hardest question in the exam. It wasn't done particularly well, but it was a really, really hard one. So what I started with was noticing, well, it's a quadratic on the top, so let's factorize that quadratic. So if you factorize that quadratic, we're going to have, we'll carry on over here, that's going to give us x minus 3 bracket x minus 3, and then that is divided by 10x squared plus 6. And if you notice on the top there, that's the same bracket twice. So that actually becomes a perfect square. So carrying on a bit more, that's going to become x minus 3 squared over 10 minus x squared plus 6. So let's now that we've got this expression here, let's now start thinking about the numerator and the denominator separately. So the numerator, so this is another explaining question. So the numerator would factorize to x minus 3 squared, which is a perfect square. So regardless of, so basically in this scenario here, if x minus 3 ends up being negative, it's going to become a negative squared, which is positive. And if x minus 3 is positive, a positive squared is still positive. So regardless of which way around it is, we're going to have a positive part for the numerator. So if x minus 3 is positive or negative, its square must always be positive. Because, let's write positive times positive is positive, or negative times negative is equal to positive. So from that, we've confirmed the numerator is always going to be positive no matter what. The same thing can be said about the denominator, because the denominator has a squared outside that bracket there as well. So that's going to be a perfect square plus 6. So the perfect square is always going to be positive, and the denominator will be 6 more than whatever that positive answer is, which will basically make it more positive. So that denominator must also be negative for the same. So that denominator must also be positive for the same reason. So scroll on and up, we're just going to have the same kind of writing over here. So the denominator is also, just with my bad writing there, is also a perfect square. Which will be positive for the same reasons as the numerator. The plus 6 will just make it more positive. Okay, so now that we've done that, we've settled on the numerator must always be positive, the denominator must always be positive, and a positive divided by a positive is always positive. So as the numerator and denominator both must always be positive, we know that positive divided by positive is equal to positive, and therefore the given expression must always be positive. Therefore, the given expression must always, gosh, very messy handwriting here, must always be positive. Oh geez, I don't know what's happened. Must always, there we go, be positive. Okay, so that wraps up 41. You needed to have a really good summary. You did need to very clearly say the numerator and denominator must always be positive, and positive divided by positive is positive. So if you said something to that effect, you would have got your full marks. So the very final question of the algebra section was the last excellence thing, question number 42, and we've been asked to solve this expression. So this expression here, it's got a fraction, technically comes from the year 11 curriculum, that's why it's kind of the upper end of the excellent stuff. But I guess the important thing to note is the numerator and the denominator are both kind of locked in to their places with those brackets. So the only thing we can really do is move the denominator over to the other side. And the denominator is currently division. Division becomes multiplication. So that's going to become negative 4 bracket 7 minus 2p. And that will be equal to 2p plus 3. So that unlocks the numerator on the top. The denominator's been moved over, but it's still kind of locked away in a bracket. So I now need to use my rainbow method to expand that. So that times that is minus 28. That times that, positive 8p. And that there should be equal to 2p plus 3. I can now simplify. I can see 8p over here, 2p over here. So that means the left-hand side has 6 more. So I can use that as part of my answer. So that's going to be negative 28 plus 6p, because of that 8p and 2p over there cancel. And that there is equal to 3. I can then solve. So negative 28 moves to the other side. It becomes positive 28. So that's going to become 3 plus 28. So 6p is equal to 31. That 6p moves to the other side is divide by 6. So that's 31 divided by 6. So p is equal to 31 over 6. If you wanted to, you could convert that into a decimal. I wouldn't suggest it, but that there would have been 5.166 recurring if you did leave it as a decimal. But I think the fraction answer there, 31 over 6, was the best answer for that particular question. So that wraps up the 50% algebra section. What we're going to do now, we're now just going to scroll down to the optional algebra or the optional extension section. And again, I just want to emphasize, this doesn't count towards your overall grade. This was just a chance for you to show your extra algebra skills. Sorry, not your extra algebra skills, just your extra skills generally. And this is for people in the extension classes or maybe trying to put forward a case next year to be included in one of those extension classes. So let's get into question number 1. So 120 students. So 120 students were asked if they liked mathematics or if they liked English. And we know the following. So all of these here were given to us. And this question was quite tricky. I know it's a Venn diagram one. So that 120 means each of the groups, so I'll call them circle, square, plus sign, circle, triangle, and then maybe a star. All of those there have to add to 120. So we know that 107 liked one or at least one of those subjects. So what that means is the circle plus the triangle plus the star, all of those had to get to 107, but we didn't know anything at this stage here to figure that out. We then know that 75 students liked mathematics. We don't really have a mathematics circle, so let's call this circle here mathematics and this circle here of English. So we know the circle and the triangle must add to 75. And then finally, we know that 70 students said they liked English. So that means the triangle and the star liked to 70. So this one here was a really, really, really tricky question. So the only thing we do know is 107 people liked one of the subjects out of 120, which means the other 13 must have not liked either of them. And those people are going to be the plus sign. So those people are going to be the people sitting outside that I've circled there, sitting outside both the maths and the English circles. The remainder, and this is where the trick comes into play, come from these two numbers here. So 75 plus 70 is 145. So we know 145 are these three portions here added together. But we're only expecting 107 of them. So what that means, or the difference between these two numbers is 38. So that means 38 students sit in the middle, and they've been counted in both groups, in the English group and the maths group. And then from that, we can then figure out the maths group. So the whole math circle needed to be 75. So 75 minus 38 is 37, which goes over here. And then 70 minus 38 is 32, and that must go over here. So that was a really, really tricky one. So figuring out who was double counted was the trick to get there. And answering the actual question, calculate the probability that they liked English given they liked maths. So we need to find the probability that they liked English given they liked maths. So the total maths group was the 75 people sitting in the maths circle, and of those 37, of those 75, 38 of them liked English. So if you got the Venn diagram correct, you got a tick. If you got the probability, the conditional probability correct, you also got a tick, and that was 2 marks to contribute to your extension section. So we got another one here. So this is question number 2, another probability question, but I've messed around with a bit of algebra in here to make it quite difficult. So a bag of hockey balls contains a mixture of pink and yellow hockey balls. There were 32 hockey balls in total. And a student grabbed 2 hockey balls at random. So you can kind of see it's going to become a probability tree. The first layer being the first ball, the second layer being the second ball. That's kind of the vibe I'm getting from the question. We've been told if N represents the probability of a pink hockey ball, so N representing the probability of a pink hockey ball, and there is no replacement, so they've taken it out and they don't put it back, show that the probability of a student getting one of each color is this here. Gosh, so this looks like a bit of a messy question. So let's start by drawing the tree, which I kind of deleted, but I'll need it back anyway. So we're going to start by drawing the first branch. So the first ball that the student picks could be pink or yellow. And we know there were N number of pink hockey balls. So that means that probability would be N over 32. Whatever N is, we don't really know what it is, but we can form an algebraic expression with N. And we know if we do 32 minus N, the leftover there must be the number of yellow balls. So 32 minus N over 32. So that's going to be the yellow section. So we're now going to do the second ball, and this is where it's going to get really messy. So the second ball, so if we've drawn a pink one, we could draw a pink one or we can draw a yellow one again. So there were N pink hockey balls, and we've drawn a pink one, which means there now must be N minus 1 pink hockey balls. And that's over 31 because I've already drawn one of the hockey balls. There's no replacement. And initially there were 32 minus N yellow ones. That hasn't changed. So it's going to be 32 minus N over 31. So that's my expression for the yellow ones. I'm now going to repeat again. I think I'm going to run out of room here. So we've got pink and yellow as the second possible options. There were N pink hockey balls, and we drew a yellow one. So that means there's still N pink hockey balls. So that's going to be N over 31. So the 32 has dropped to 31. And there is now one less yellow hockey ball. So that there would have been 32 minus N. I'll draw it down the side here. So 32 minus N. And we're minusing 1 off that. So that's going to become 31 minus N. So we're going to have 31 minus N over 32, over 31 yellow hockey balls. Okay, so I've drawn the tree. So that tree's been pretty messy so far. I'm going to scroll down a little bit to give us more room for working. I think we're going to need it. We've been asked to find the probability of one of each color, and we somehow need to simplify that algebraic expression to match the one that we've been giving. So one of each color would represent these two branches here in the middle. So we've got probability, one of each. That's going to be equal to this times this. So that's going to be N over 32 times by 32 minus N over 31. And we're going to add on the next branch, which is this times this. So that's going to become 32 minus N over 32 times by N over 31. And hopefully you've noticed a pattern here. If you simplify both of these fractions, they're actually going to end up being the same fraction because the numerators and the denominators are the same. They've just been switched around. So if we multiply the numerators together, so top times top, that's going to become N. So it's going to become N bracket 32 minus N over 31 times 32, which just doing on my calculator is 992. And we're going to do the same on the other side. That's also going to be N times 32 minus N over 992. So you can see you got the same fraction twice. So it basically means you got 2 of that. So what we'll do is we're going to merge those together. That's going to become 2N bracket 32 minus N over 992. And that matches the initial expression that we had there. So if you were able to work through all of that, that was another 2-mark question. It was a combination of your algebra, fractions, just a mishmash of everything, wasn't it? How did the marking schedule work? I've deleted some stuff by accident. But the marking schedule was if your tree was correct with the right expressions, you were given 1 mark. If you were able to prove and get to that final result with the correct working, that was your 2nd mark. So moving on up to question number 3 with 1 mark. Factorize these things here. So luckily this one here, I've noticed that 4a squared and 9, those are both square numbers. So I know this is going to be a perfect square scenario. So what I'm going to do is I'm going to square root 4a squared. That's going to get me to 2a. I'm also going to square root 9, which is going to get me to 3. So this here then would be 2a plus 3 squared. You could have factorized this using the grouping method, which was a bit more complicated, and you would have still got to the same answer. It just would have been far more work and unnecessary, really, given there was a lot simpler way to do that. And that's why it's important to know the different types of quadratics and be really confident being able to spot them. Okay, so we're now to question number 4. This one here does require the grouping method that I just mentioned because 24 and -5, none of those are square numbers, so there's no trick to this one. You just got to kind of do it the old-fashioned way. So let's start off by doing the grouping method. So I need to do 24 times 5, or times -5. So if I do that on the side here, 24 times -5, that's going to get me to -120. So I now need to think what numbers multiply to this -120, but add to the 14 that's kind of in the middle of that expression.
And this is going to be a tough number, so let's start writing down all the numbers that multiply to 120. And because it's negative, we're eventually going to realize, well, one of them's got a difference of negative, or one of them's got a difference of 14, and we'll be able to spot the answer that way. So it could be 1 times 120, that's got a difference of 119, so we know it's not that. 2 times 60, that's got a difference of 58, so we know it's not that. 3 times 40, that's got a difference of 37. We know it's not that, but we can see that gap getting smaller every time. 4 times 30, that's got a difference of 26. Then we've got 5 times, gosh, is that 24? That's got a difference of 19. We must be getting close. We've got 6 times 20 is the next one. And bingo, 6 times 20, that's got a difference of 14. Because it's positive 14 in the middle of my expression, that means the biggest of these has to be positive. So it's going to be positive 20 and it's going to be negative 6. Those are going to be the two numbers that I need to use for my grouping method. So we're going to split that up. So it's going to be 24x squared plus 20x minus 6x minus 5. I'm now going to factorize my first group. So remember, the first group is the first pair. So these need to be factorized, and then these need to be factorized. So they'll be all factorized separately. So the first group will factorize to, was that 4x have in common, and that will be 6x plus 5. The next one have a minus 1 in common, which will be 6x plus 5 as well. And we can see that same bracket, 6x plus 5 coming up twice. That's my common bracket. So I know I've done it right because I've got that same bracket coming up twice, 6x plus 5. And then my leftovers, which is the 4x and the minus 1, they come together to form that second bracket, 4x minus 1. If you're able to get that, and I should have noted, basically, if you got the right answer, you got the tick for those ones. So question number 5 in the optional section, last two questions of the whole exam actually, more factorizing questions. And in this case here, hopefully you've recognized straight away, that's a difference between two squares. So it's similar to question number 3. If we square root x squared, that gets us to x, square root b squared, that gets us to b. So our factorized version will be x minus b, x plus b. And again, another reason, if you got that right, tick, another reason to be really, really confident with knowing your different quadratics and how little shortcuts to factorize them can be. The very last question, I've just tried to throw in a whole bunch of mishmash to see what you can make of it. And the first thing to note is there are 3 parts, so it's kind of initially giving you quadratic vibes. But then when you look at the powers, there's not a lot of relationship going on with these powers. So it's actually not a quadratic, it's just a regular single bracket factorizing, but there's just going to be 3 things left over in that bracket. So let's have a look at all these. Looking at the numbers, we've got 28, 32, and 40. All of those have a 4 in common. So a 4 is going to take out. We can see they've all got a pi in common, and pi is just number, and I can take that out and factorize that like any other number. And then let's look at the letters. I've got a to the power of 5, so I've got 5 over here, 2 over here, 4 over here. So the smallest amount that they have in common is 2, so we'll ignore that pen warning given we're so close. So that's going to become a squared, and we're going to repeat the same for the b's. We've got 4 b's here, 5 b's here, 3 b's here. The smallest b's that they have in common is 3, so that's going to become b cubed. So it's a bit messy, but that's all of the common factors that they have in common. So now that we've done that, we're going to go 28 pi a5b4 divided by the highest common factor, and that will give us the part that goes here. We then repeat this process, that will give us the second part, and then we repeat it again to give us the third bracket, the third part, which we then close the bracket on as well. So if you've done it right, you would have got, in the first bracket, you would have got a 7 a cubed times b, and then you would have minus 8b squared, and that's because we took out all the a's, and we had minus 10a, and that's because we took out all the b's for that last one there as well. So if you were able to get that final answer, you would have got your mark there. So that was a huge marathon video. It took a lot of extra time explaining all the questions, but hopefully you found it useful. Now this exam is going to be fairly similar to a real mid-year exam, so make sure you are confident with all these skills, and be prepared. There will be other types of questions coming up. So make sure you're aware of everything that could come up, and make sure you're really confident with them as well. Thanks heaps for watching. Hopefully you find it useful.